Hello ladies and gentlemen, we're going to start our next unit, polynomials, and before we get too much into this end behavior stuff, I want to just review some vocabulary. This is all stuff that you're going to hear pretty regularly, so you need to kind of know what I'm talking about when I use these words. The first thing, when we describe a polynomial, we sort of have like a first name and a last name. We talk about it in terms of its degree, and we talk about it in terms of how many terms there are. So for example, if you just give me the number 7, the degree of the number 7 is 0. There's no variables, and we call that a constant. And if it's a single term, well, we say, hang on, this doesn't make any sense. No terms doesn't make any sense. So the degree 0 is a constant, and you have to have a term to name it, so that doesn't make sense. But if it's degree 1, what that means is like x to the first. So think like slope-intercept form, 5x plus 5. This is x to the first, so that's called linear. It's called linear because when you graph it, you will get a line. So if it's 5x to the first, that is a linear polynomial, and if there's a single term, so if it was just 5x to the first and there wasn't a plus 5, that would be called a monomial. If it's one term, it's a monomial. If it's degree 2, so degree 2, something like x squared plus 2. Degree 2 is a quadratic. You will get a parabola when you graph it. And this has 2 terms, so this would be called a binomial. So this is a quadratic binomial. If it was 3 terms, so let's say x cubed plus x squared plus x, so this has got 3 terms, so that's a trinomial, and it's the highest degree 3, so this is a cubic trinomial. It's a cubic because it's degree 3 and there are 3 terms, so it's a trinomial. If you make it degree 4, after cubic comes a quartic. Quart. Q-U-A-R-T. 4 quarts in a gallon. It's a quartic. And if it's got 4 terms, we're just going to say, look, we're going to start to generalize this and say this is a polynomial with 4 terms. We'll just say it's a polynomial with 4 terms. Polynomial with 5 terms. After 3, we're not going to have names that we use regularly. So polynomial with 5 terms. And then if it was just like, if there's 10 terms, you would say it's a polynomial with 10 terms. So we'll say if it's n, it's a polynomial with 10 terms. Or let's just say n terms. N terms. Okay. Degree 5 is a quintic. And after that, we'll just say it's degree n, or nth degree polynomial. So in terms of degree, we have constant, linear, quadratic, cubic, quartic, quintic. After that, we're not going to learn all the names of all the prefixes. We'll just say it's nth degree. Number of terms, so if we have no terms, you can't name nothing. Single term is monomial, 2 terms is binomial, then trinomial, and after that, we'll just say 4, 5, 6, if it's 10 terms, n terms, whatever it is. Okay. So what we're going to first do is talk about just some generic stuff here about what you're looking at when you look at this. This looks really scary, but I'll throw some numbers in there so I can reference it. So we'll say like 7x to the 5th plus 3x to the 4th minus 2x to the 3rd, and I'll say dot, 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 and then we'll just say plus, I don't know, x minus 6, just so I can reference all this stuff. So the polynomial has degree. The degree is the highest one of all of your exponents, and you make sure you're in standard form, which means they're in descending order. So here I have 5, 4, 3, and then I have 1, and then degree 0. So the highest degree is the degree of the polynomial. If you say it's n, then I'll say it's degree n. Whatever the one in front, here it's 5. Whatever the one in the front is the degree of the whole polynomial. The numbers in front of the polynomial, so a sub n, all these a sub 1, these are the coefficients. The numbers in front of the variables are called the coefficients. Coefficients. Oh, I missed something. C-O-E-F-F-I-C-I-E-N-T-S. Coefficients. Okay. The number a sub 0, the one at the end, that's called the constant term. It doesn't have a variable, it's constant. So if you plug in 0, you will get, in this problem, negative 6. It's also the y-intercept if you graph it. So that's sometimes helpful to know that that's your y-intercept. The leading coefficient, the one in the front. So here, in my example, it's 7. If you just say it's a sub n, it's the one in the front. That's called the leading coefficient. And the leading term is both the coefficient and the variable. So the leading term would be a sub n x to the n. In my problem, it would be 7x to the fifth. That's the leading term. If you just know the leading term, you can tell quite a bit about polynomials, and that's what we're going to spend some time talking about today. So the first thing, let's just kind of go through practice using all that vocabulary. The leading coefficient is the one in the front. If this is the only one, then the leading coefficient would be 4. Here, the leading coefficient is -5. Here, the coefficient is 6. Here, the leading coefficient is -4, and then -19. The number in the front is the leading coefficient. The degree is the highest degree in the polynomial, so here there is no x. You could say x to the 0, so that's the best you can do. The degree of this is 0. The degree of the first one, or I'm sorry, the second one, is x to the first, so that is linear, degree 1. This is degree 8, this is degree 6, and this is degree 5. You're looking at the highest degree anywhere in there. The leading term is the entire first term, so here the only one you have is 4. Here it's -5x, here it's 6x to the 8th, here it's -4x to the 6th, and then -19x to the 5th. And then the constant term, well, the constant term is the whole thing in this one, so the constant term is 4. What is the constant term in this one? 6. Here you don't have anything, so what did you add on the end? You say, well, plus 0, -3, and then again, plus 0 is the constant term. So just kind of using some of those vocabulary words we were talking about, and now what we're going to do is see if we can create some polynomials. This says create one that's got degree 8 with 4 terms, a leading coefficient of -6, and a constant term of 11. So -6x to the 8th has to be the front because it's got a leading coefficient of -6. It's got degree 8. I have to have 11 on the end. Let's see. Degree 8, 4 terms, leading coefficient. I have everything but the 4 terms. So all I need to do is make up 2 terms that don't have degree 8 or degree 0 because they can't be like terms. So let's just say plus x to the 7th plus x to the 3rd. You can skip all the degrees, like you don't have to have x to the 6th, 5, 4, 3. Like you can skip them. There's gaps there. That's fine. You have x to the 8th. That's the highest one, so this is degree 8. There are 1, 2, 3, 4 terms. The leading coefficient is -6, and the constant term is 11. So that is one example, but these could be a lot of different things. A monomial with degree 1. So a single term with degree 1. How about 7x? It's a single term and it has degree 1. Write a polynomial using the following coefficients. So I'll just say 3, -7, 2, 8, -4, 6. And I'll just go ahead and say, all right, x to the, let's see, x squared, x cubed, x to the 4th, x to the 5th. There you go. That's one example. I could probably do that with other ones. You don't have to have them in order, but that's just one example of a polynomial with those coefficients. Find the zeros of each polynomial. Okay, so we're going to practice doing a little bit of solving now. So this is definitely a review. This is a quadratic, so I'm going to factor that. And to factor, I need to find numbers that multiply to -6 and add to 1. So that would be plus 3x minus 2x. Then I'll do GCF of the first two, 2x plus 3, minus the GCF of those two. They're co-prime, so we'll just put 1, and that makes this 2x plus 3. And then our factors are 2x plus 3, x minus 1. And I want to know where their zeros are, so when these equal 0. So that's when x equals -3/2 or x equals 1. So if I were to graph this, I would see x-intercepts at -3/2 and a +1. So that's a quadratic. Well, we're going to work with higher degree polynomials for sure. So here's a cubic. Can we do a cubic? Well, it's set up for factoring by grouping. So I'll do the GCF of the first two, x squared, x plus 7 plus. GCF of the second two is 2. And now I have x squared plus 2 and x plus 7. So I want to know when they're equal 0. Well, one of them is -7. This factor, if you plug -7 in, you'll get 0. The other one is trickier. So if you say x squared plus 2 equals 0, then to solve that, you would subtract 2 on both sides, and then you would square root both sides. And then this is the square root of a negative. So we've been dealing nothing but with real numbers, but we're going to actually start to find some non-real, some complex zeros as well. So I'm going to just say this is plus or minus, because every time you square root, you got to remember plus or minus, I radical 2. Since it's negative, you're going to say this is an imaginary number, and it's imaginary radical 2, and it's plus or minus. So there are 3 zeros, plus I radical 2, minus I radical 2, and then at negative 7. Let's do one more, finding zeros. So I'm going to try and factor it, so I need numbers that multiply to 2 times 1, and add to 8, and nothing's going to multiply to 2 and add to 8. So if you can't find it by factoring, then that means you need to use the quadratic formula. So let me remind you of the quadratic formula, and we'll go ahead and work through that. So for the quadratic formula, we're going to do, I like to do the discriminant. The discriminant is the part under the square root. The radicand is called the discriminant. And you can learn some stuff from the discriminant. We'll talk about it later. I like to do that first, so I kind of know what's going to happen. So I'll do b squared minus 4ac. So 64 minus 8. 64 minus 8 is 56. So I'm going to fill this in now. I have the opposite of b, so negative 8 plus or minus radical 56 over 2 times 2, which is 4. So negative 8 plus or minus 56 can be factored. That's 2 times 28, which is 2 times 14, which is 2 times 7. So I'm going to have to simplify that. So then this is going to be, let's see, negative 8 plus or minus 2 radical 2 times 7 is 14 over 4. And the last thing I'll do to simplify this is distribute this 1/4. So negative 2 plus or minus 1/2 radical 14. Using the quadratic formula can be a little trickier when you start to get to complex numbers and all those sorts of things, but you definitely need to be able to do that. So we're going to hit these things up quite a bit more when we get further into the unit, but today we're going to focus mostly on end behavior. So let's move on. We're going to talk about the end behavior of graphs, and we're going to use some different notations here to describe the end behavior. So first, let's just do it. We won't talk anything about limits right now. We'll just say, as x goes to infinity. So as x goes to infinity, another way of saying that is as you go to the right. X going to infinity is going to the right. So as you go to the right, what does y do? As you go to the right, y goes up. So we'll say y goes to positive infinity. Similarly, we have to describe what happens as you go left. So we'll say as x goes to negative infinity. So as you go left, what does y do? As you go left, y goes down. So we'll say y goes to negative infinity. Let's look at this next one. As x goes to infinity, as you go to the right, y goes down. So y goes to negative infinity. And as you go to the left, because that's what x goes to negative infinity is saying, as you go left, y is going down. So it's also negative infinity. What we're going to try and do is just connect the polynomial to the end behavior. You should be able to just look at the equation and tell me what the end behavior is going to be. So first, I'm going to graph each of these and we'll look at them. We can do some of this without the computer. So leading coefficient is, here it's positive, and the degree of the polynomial is odd. Here the leading coefficient is negative, and the degree is 4, so it's even. Here the leading coefficient is positive, and the degree is 6, so it's even. Here the leading coefficient is negative. It's degree 7, so that's odd. The leading coefficient is negative, and it's degree 1, so that is odd. And then this is positive leading coefficient, degree 2, which is even. This is a negative leading coefficient, degree 8. 8 is even. This is a positive leading coefficient, positive 2. I don't know what's up with that symbol. But positive 2, and then it's degree 3, so this one is odd. Now we're going to see if we can spot the end behavior for each of these. So we're going to say what y does as we look at x. So let's graph them. I have these all typed in, 4x to the 5th. So let's see, where's the first one? 4x to the 5th, there we go. So you can see as you go to the right, it goes up, and as you go to the left, it goes down. So as you go right, as x goes to infinity, y goes up, and as x goes to the left, y goes down. Okay? So the next one. This one, as you go to the right, y goes down, and as you go to the left, y goes down. So if y goes down on both sides, we're going to say y goes to negative infinity, y goes to negative infinity for both of them. What do we got for the next one? So this is positive even. You'll notice they both go up. So positive even, y goes to infinity, on both ends. Negative odd. What's negative odd do? This is negative odd. So as you go left, y goes up, and as you go to the right, y goes down. So as x goes to infinity, y goes to negative infinity, and as x goes to the left, y goes up. Okay, this is saying as you go right, y goes down. As you go left, y goes up. Let's see. Negative 2x plus 6. So this is a line. As you read left to right, it's decreasing. So as you go to the right, y goes down. And as you go to the left, y goes up. Positive even. Well, we're starting to get to, we've seen all the possibilities now. So positive even. We've seen a positive even. It's going to be like this. Y goes to infinity and y goes to infinity. So let's see if that makes sense. If I look at this next one, positive even. Oh yeah, it goes up on both ends. All right, I'm starting to remember this. Negative even. We have a negative even somewhere, don't we? Yeah, y goes down on both ends. Negative infinity, y goes negative infinity. So is that right? Let's check it. Yep, down on both ends. Good, okay. Positive odd. Positive odd. So that was the first one. Y goes up as you go to the right. Y goes down as you go to the left. Does that look right for the last one? Yeah, as you go up, as you go left to right, it's increasing, it's going up. Okay, so we're looking for a pattern here. When it's positive, actually, first let's look at whether it's even. This is probably easier. If it's even, so look at all the ones that are even. For all of the even polynomials, they have the same end behavior for both ends. It's either negative, negative, or positive, positive. Positive, positive, negative, negative. So when you have an even degree polynomial, then the endpoints are going to go in the same direction. When you have an odd degree polynomial, they're going to be opposites. You'll have one that's positive and one that's negative. One that's negative, one that's positive. One that's negative, one that's positive. The way you tell which way it's going to be is if it's positive and it's odd. Let me kind of summarize this. If it's positive and odd, it's increasing. Maybe let's see, how can I do this? We'll say even, odd, positive, negative. Okay, so if it is even and it is positive, then it's going to look like this. It's going to have this, the endpoints go in the same direction and it opens up. If it's negative and it's even, the endpoints still go in the same direction, but it opens down. If it's positive and odd, think of a positive slope. As you read left to right, it's increasing and the endpoints go in opposite directions, so something like that. If it's negative and odd, it will be decreasing, like a negative slope. So that's sort of summarizing all of the stuff that we've done. Now the last thing we're going to do is introduce limit notation, which is saying the same thing, but it's a slightly different way of writing it. So let's see if we can do this using limit notation. So we're going to say the limit of f of x equals as x goes to. We're just kind of reorganizing this a little bit. So first, it's always going to be as x goes to infinity and as x goes to negative infinity. You have to have one for each. You're going to go to the right and you're going to go to the left. So since this leading coefficient is positive and the degree is odd, if it's positive odd, it's going to look something like this. So as you go to the right, y goes up. So the way we're going to say that in limit notation is the limit of f of x as x goes to infinity, as you go to the right, it goes up to positive infinity. As x goes to the left, negative infinity, the f of x, the y, approaches negative infinity. So as you go right, it goes up. As you go left, it goes down, because it's positive and it's odd. Here, this is negative leading coefficient, and it is also odd degree. It's degree 3. So if it's negative, as you read left to right, this one would look something like that, which means as x goes to the right, as x goes to infinity, y goes to negative infinity. We're going to use limit notation. And as you go to the left, as x goes to negative infinity, y goes to positive infinity. This is positive 1, and it's even, so this one should look like a w or something like that. It opens up because the leading coefficient is positive and the degree is even. So as you go to the right and as you go to the left, y does the same thing. Y goes up. If it's even, you know they're going to be the same. They're both positive because it's going up on both ends. This one is negative odd, so negative odd looks like this. Negative odd. It's a negative leading coefficient and it's degree 5, which is odd. So as you go to the right, as x goes to infinity, y goes down to negative infinity. And as you go to the left, y goes up to positive infinity. That's the worst infinity sign. Come on. Oh, my light just clicked off. Last one. This is a positive leading coefficient, and the degree is 11, which is odd. Remember, we're talking about this exponent. It's degree 11, which is odd. As you go to the right, well, this is positive odd, so positive odd look like this. As you go to the right, y goes up, and as you go to the left, y goes down. So the main things you need to remember are right here in this page. If we're going to summarize all of our end behavior, if it is positive, it's going to be increasing. It's going to go up as you go left to right. If it's negative, it's going to go down as you go left to right. The main things that you want to keep track of as well are that if it's even, they're going to go in the same direction. So either both up or both down. And if it's odd, they go in opposite directions. So if you can kind of remember that, then the rest of these are going to be really easy. So that's mainly that's the stuff that you need to understand for end behavior. So go ahead and be sure to hit that like and subscribe button.